Hello, and welcome to today's 8th webinar in the On the Move webinar series, Conquering Palletizing Challenges in Manufacturing and Warehouse Environments, brought to you by Intelligrated. I'm Tracy Niehaus, Marketing Manager for Intelligrated, and I'm your moderator today. We have just a few announcements before we begin. Please note that this presentation's audio is provided by phone number or through your computer sound system, so be sure to turn up your computer's volume. You may ask an online question at any time throughout today's presentation by clicking on the question mark icon located in the floating toolbar at the edge of your screen. Simply type your question into the text area and hit send. Please keep the send to default set as all panelists. Questions will be addressed at the conclusion of the presentation with the exception of technical questions that can be asked and will be answered real time. Please note, we recommend that you be hardwired when attending this webinar. A Wi-Fi connection may result in lag time in slides updating, graphics loading, etc. Additionally, if you are joining us via the WebEx mobile app, you will not have the ability to view videos or animations included in this presentation. Today's webinar includes polling questions. Please feel free to answer these questions when they appear. We will be sharing the results real time during this live event. If you'd like to revisit key sections of today's webinar, it will be available on demand at intelligrated.com/on-the-move approximately 24 hours after this live event. You'll also receive an email in a couple of days with a link to the recorded event. Now on to the presentation, Conquering Palletizing Challenges in Manufacturing and Warehouse Environments. Discussing today's topic will be Frank Pellegrino, Vice President of Machine Products, and Matt Wicks, Vice President of Product Development for Manufacturing Systems. Frank has nearly 40 years of experience in the automated material handling industry in a variety of positions, from estimating and design engineering to product management and AutoCAD implementation. Matt has more than 18 years of experience in the material handling industry with expertise in the areas of controls and software integration for high-volume facilities, as well as unique build-to-order fulfillment solutions. And with that introduction, I'll turn it over to Frank and Matt, and the webinar will now begin.
Good afternoon, everyone. I'm Frank Pellegrino. Matt Wicks is alongside, and today's topic, as Tracy said, is palletizing. First of all, palletizing is one of those functions that can be viewed somewhat as mundane and may not get the focus that it typically deserves until something goes wrong. And when the palletizing function is not up to the level of performance that you need, that's when the entire facility can feel the pain. So today's objective is to help give you a broader perspective and some things to think about as you're looking at either your existing palletizing operation or looking to upgrade. So the challenge is knowing what issues to focus on, how to approach an upgrade, and just simply recognizing that maybe palletizing is a hindrance to your existing operation. There's many choices today, from traditional, what we would refer to conventional type palletizing machines, dedicated use machines. Certainly robotics plays a big role in palletizing today, and then we're seeing many applications for hybrid. We'll talk about all these in greater detail. However, before we dive in, we like to hit you with our first polling question, just to get a little feedback from you. And what is your current operation? Are you manually palletizing? Are you using conventional equipment, robotic? None of the above. So we'll take a few minutes. If you can click on the answer there and give us a little feedback, we'll share that with you so you as an audience can see what the prevailing solution is today.
And one of the other things that we'll be talking about today has to do with if you're transitioning from a manual palletizing solution into what are the things you should consider for automatic palletizing, whether it be a conventional machine or a robotic machine.
Exactly. And if you are manually palletizing today, as we'll talk later, there's actually some situations where that does make sense, but ultimately, wow, okay, 42% manual. I don't know if everybody can see the results on the screen, but we have 42% manual palletizing, 8% conventional, 8% robotic, and 42% none. So let's move on then to the presentation. First of all, there are any number of conditions driving the need to invest in palletizing. We'll talk about each one of these in a little bit more detail. You know, the obvious one is desire to improve operating efficiency. And we'll go, I'm not going to step through all 6 of these here because we'll talk about each one in a little more detail. The number one point I want to make is that when you're looking at a palletizing solution, you have to think in terms of a system. I've seen many examples where customers are dissatisfied with the current operation, and this can even apply to manual. If you have issues delivering the product to the palletizing cell or machine, it may look like a palletizing issue when really it's a system. For example, the conveying system must be able to deliver product back to back. That is, no gaps, no air in the flow of cases. A little bit of air can have a huge impact on performance. The layout is hugely important. If there's a curve right before a palletizer infeed, for example, that makes controlling the system very difficult and very tough to maintain that back-to-back flow. Accumulation line pressure can be deadly. So I'm bringing these up just as things to consider when you're looking at palletizing. An analogy I like to sometimes use is think about yourself in a traffic jam and you're a case on a conveyor system. As you're approaching a stoplight, you see it turn red in the distance. You continue to travel for, say, 10 seconds before coming to a stop. Now the light turns green. It might be 10, 15, 20 seconds before you start to move again. This gets into the concept of what we call negative accumulation, where the time that you buy with accumulation conveyor is actually less than the time it takes to restart upstream process. So in that situation, you're actually losing by having accumulation. It takes longer to get the last case of the train moving. So the most frustrating thing is you're at a stoplight, there's long cars in front of you, the light turns red again before you even start to move. That's and then you get a good idea what we're talking about with negative accumulation. So the point here is truly think about palletizing as a system. If you just focus on the machine or the robot, you could have a really good machine or a really good robot, and it's going to come up short in satisfying your needs. Another big trend today we see is in packaging. This has a very big impact on your palletizing capabilities. I'm not going to go through all these bullet points, but suffice to say, it's all about less. Many companies like to use the word sustainability, and I think that's a fine objective, but often it gets down to cost. So by taking packaging out, we're saving cost, saving materials.
So one of the interesting things here is, so with the poll result being a lot of manual palletizing, this is a key factor here because people can handle these wide variety of different packaging challenges really just inherently. People are very good at doing those things. To have an automated machine handle some of these more challenging packaging types really requires some substantial amount of expertise and a lot of different types of equipment to really efficiently handle these things. So when you're considering moving from just a pure manual operation to an automated solution, take into consideration, you have to take into consideration what types of product that you're handling and the challenges associated with handling those products.
Yeah, and Matt makes an excellent point, because many times today the product that is being palletized is actually the package that the consumer picks up off the shelf. So secondary packaging is virtually going away today. The other consideration is if you're in a distribution environment, we're seeing an increase in the use of totes for order fulfillment. Totes present some special challenges, and we'll come back to this a little bit later and talk about some of the viable solutions for palletizing totes, including sortation and order fulfillment. It's no secret there's an explosion in the number of SKUs. This puts further pressure on your palletizing system, making changeover rapid changeover, toolless changeover, very important. Otherwise, you spend your entire day adjusting equipment to handle other packages or other SKUs. Number 4, because packaging is changing so rapidly, that's also having a big impact on the nature of the loads. The club stores want display loads that they can park at the end of an aisle. Very often there's a desire to have graphics to the outside of the load for display purposes. Because secondary packaging is becoming very weak or going away, often there's the need for additional dunnage in the load, such as tier sheets, slip sheets, corner boards, and then certainly labeling is very important today, tracking the product and having barcode scannable labels on every pallet load.
Yeah, again, just to re-emphasize, in a manual operation, a lot of these types of items are being addressed by the human workers. Basically, all the wrapping, if there's any difficulty in handling and moving the loads around, those are all being handled by the individuals. So when you transition from that manual operation into handling those loads in an automated fashion, there's several other things that you need to take in consideration. Load stability, like what we're showing here in the picture, the corner bars are being put up there, automated wrapping systems, all those types of things really need to be considered as it relates to the load configuration.
One of the biggest factors today that we're seeing is evolving safety standards, not just industry standards, but many of you, I'm sure, have corporate safety standards that are evolving and very rapidly. So equipment that may be perfectly functional, perfectly reliable, you're having to consider either replacing it or spending large sums of money to upgrade it. It's not uncommon today. We'll see situations where customers are having to spend $150,000, $200,000 to upgrade equipment. On the screen, you see a list of some of the typical things that are requirements today, and it continues to evolve and continues to become more stringent. So the final item that we're seeing impacting a drive towards investing in palletizing is labor markets. Obviously, if you're manual palletizing, you know the challenges that go with that, availability of labor, the potential for increased minimum wage, and then certainly the availability. It's a job that people don't enjoy, don't like, and so keeping people on the job is tough. And then finally, there's always that risk of injury, particularly if you're dealing with a heavy product. Okay.
Go to the poll.
So let's go to polling question number 2. Of these factors, which are the ones that are driving your consideration to investing in or upgrading palletizing operations?
So I'll chime in here a little bit about the challenging labor markets. What we've seen is a lot of these labor markets are pulled around geographically dense areas, and so as retailers specifically are consuming a lot of those manual resources, a lot of the manufacturing facilities as well as the other retailers are struggling to find the labor to be able to manage those the needs that they have. So automated palletizing solutions, and for that matter, other automated solutions are becoming more and more viable.
So in fact, I was with a customer yesterday. You would think that desire to improve efficiency would be at the top of the list, as is the case here. 40% of you have said desire to improve operations. Interestingly enough, trends in packaging and SKU explosion rated fairly low here. We only had 20%. Between the two, this customer I was with yesterday, it was all about that. He sees an explosion coming at him, a wave. He knows his existing equipment can't handle it. So, which kind of brings up the point, maybe efficiency is your #1 driver today, but consider the future. Don't lose sight of evolving trends, the packaging changes that are going on, and the trend towards smaller packs in particular, whether it be in a DC environment or in a production environment. Packages are getting smaller and they are getting more fragile. So with that as a background, how do you satisfy this? All these objectives can be satisfied. The challenge for us and for you is to pick the right solution. So with that said, with technology today, there's many, many different viable approaches to palletizing. And manual is still a viable one in many situations, or some form of semi-automatic. But as time goes on, it's going to be more difficult to satisfy your needs with manual palletizing for the labor reasons we talked about, as well as certainly you want to increase rates, you want to increase performance. So we'll go through each one of these somewhat briefly. On the manual side, there are advantages. It's scalable, it's flexible, it's relatively low cost versus investing in capital equipment. However, we've already talked about some of the negatives. Slow, inefficient, risk of injury, and so on. So the key on the automated side, it should be fast, it should be efficient, should be reliable, should be repeatable. And all those are true except if you pick the wrong solution. That's why I've got in bold font there. You get the wrong solution, that's going to equal failure. And I've seen many examples where customers have invested in a robot, for example, and they consider it a failure because it's been misapplied. So we'll talk a little bit about robot application here in a moment. So with that being said, more often than that, the first question that the customer typically has is, what's the best solution for me, conventional or robotic? It's not necessarily an easy question to answer. There's a lot of parameters, a lot of variables that go into it. But just for the sake of understanding, let's talk about what we mean with a conventional machine. There's two basic forms of pattern formation, two methods of creating pallet loads. One on the right side of the screen, what we call conventional row forming style, where a flow of cases is fed into I apologize for the size of this diagram, but if you look at it here, a row is formed, cases are turned or not turned, and then one row at a time, we sweep that row out onto what we call a stripper plate or an apron and deposit it onto the pallet load. Pretty simple concept, very, very easy to understand, very reliable, very flexible. However, it's somewhat speed limited. If we get over here on the high speed in line, it's a continuous flow. Patterns are formed as product flows through the machine, much higher rates, however, not as pattern flexible, not as product flexible necessarily as a row forming style machine. So then we look at robots. Robots have huge flexibility, which is both an advantage and a disadvantage. On the disadvantage side, the layout, there's no end to the layout. So one of the tricks with a robotic solution is come up with the right cell design. In the middle of the screen, you can see an example of a simple 4-in, 4-out cell, which illustrates one of the advantages of a robot. I can palletize 4 different products, 4 different SKUs simultaneously without the need for accumulating full pallet loads of product, for example.
Yeah, this is really advantageous when you have, if your manufacturing facility has a lot of different products that you're needing to palletize, but not any one in particular has a very high volume. And so what you're able to do with this, coupled with sortation systems upstream, would be to send an individual SKU down one particular lane and palletize it as it's being produced and delivered to the cell.
And then some of the pictures here, a little hard to see the tooling, but the end of arm tooling is really key in effectively getting the most rate out of the robot, and we'll talk about that as we get into rates here. So how do you decide? First thing is really look at the application. What are the products being handled, construction of the cases, dimensions, and then certainly rate. What palletizing rates do you have to achieve? The number of lines to be palletized. Load requirements. Do you need corner boards? Do you need tier sheets? What are the patterns? And then don't overlook facility considerations, the footprint, the size of the layout, and then personal preference. You may just have a comfort level with a particular technology. Sometimes one or more of these criteria make it simple to decide, but not easy. Sometimes it continues to be a tough decision. But again, coming back, don't overlook the fact that it is a system. You got to think about the conveyance methods, the conveying equipment, how you're going to handle those products, how you're going to accumulate them, how you're going to get it to the palletizing cell reliably without product damage.
Yeah, to the point here, it's not necessarily just about putting items onto the act of putting an item onto a pallet. It's all of the mechanisms to get the pallet into the machine, what the slip shape requirements are, as well as upstream requirements of conveyance and sortation into the palletizing system.
And as we get into palletizing in the order fulfillment and the distribution environment, the system takes on even that much more critical importance, because sometimes we have to sequence the product, you have to sort by order, and the system is really the key in that respect. Talk about rate, just a kind of a high-level overview. Generally speaking, in a palletizing application, an industrial robotic arm can cycle 6 to 8 cycles per minute. Depending on how many units can be handled at a time, sometimes we can pick up 4, 6, 8 products, so you can do a rough calculation and get kind of a nominal idea of what type of rate you can achieve with robotic palletizing. Conventional, the rate range is large, ranging from 10, 20 cases a minute all the way up to 200 plus cartons per minute. So factors that would traditionally steer you in the direction of a conventional solution, rate being primary concern. Usually if it exceeds 30 cases a minute, I start thinking, well, maybe this is not a robot solution, maybe it's conventional. That being said, that's not a hard rule. The numbers vary tremendously. We have applications where we're doing 70, 80 cases a minute with a pick-and-place robot. But that's where rows are being formed and we're picking up 6, 8, 10 cartons at a time. Robots are known for flexibility, and they are flexible, but only as flexible as the end-of-arm tooling. So many applications, the conventional machine can actually offer you greater flexibility if you're handling display cases, cases that don't provide a good surface for picking up with a robot. So you got to think about the long-term flexibility. And beyond that, load quality. Sometimes, again, depending on the nature of the product, you can actually get a little bit tighter load, better load with a conventional machine because of the compression dams, and we're actually squeezing layer as it's being deposited onto the pallet. As far as robotic palletizing, absolutely, if you have multiple slow-speed production lines, it's almost a no-brainer. Robots, clearly the way to go, because with a conventional machine, while you can satisfy and service multiple lines, then you have to accumulate full pallet loads of product and release it to the machine in what we call a multi-line type application. If the rates are low enough, another advantage of the robot can pick the pallets, put them in place, handle tier sheets, so you're saving equipment by having the robot handle the materials that go into the pallet load. And then items like bags. If you're palletizing bags today, a robot is absolutely certainly the way to go. It's not uncommon to get 20, 25 bags a minute out of a single robot. And then if we get into vision-related applications, we're certainly in mixed load palletizing, depalletizing, where vision comes into play, robot is absolutely the right solution. Well, one of the quick, here. The final bullet there, we'll talk a little bit here in a minute about very unstable loads. The robot gives you a very good way to stack and wrap the product simultaneously by literally stacking loads on the turntable of a stretch wrap machine. So one of the key things, and if you decide, okay, robots for me, that's how I'm going to do it, you got to pay attention to the integrator. There are hundreds, literally thousands of companies integrating robots. Not all robot integrators are created equally. Matt and I could decide tomorrow we're going to be robot integrators. In Matt's garage, we'd throw a robot together and put a vacuum tool on it, and we're in business. You got to be careful about that. Size does matter. You got to make sure the company has the resources to support you. And look for RIA certification. Maybe you want to expand on that a little bit, Matt.
Yeah, the RIA has a certification program that qualifies the robotic integrators through a series of tests and criteria. Essentially, it's just establishing a higher level of comfort for individuals or companies that are purchasing robots, that their integrator is qualified and competent beyond just what you hear from the integrator.
So let's talk about hybrid solution. The hybrid can kind of give you best of both worlds. What that does is it takes robotic technology, combines it with conventional, and the idea is to capitalize on the strength of both solutions. Now, usually a hybrid solution is more expensive. And oh, by the way, this applies not just to palletizing. You see it in case packing. You see it in any number of technologies, stretch wrapping. And it can make sense beyond just the coolness factor that comes with it.
Hey, Frank, can you
sure.
give an example of a product that would be more lend itself towards a hybrid palletizer versus a conventional or robotic?
Absolutely. When we get into packages that are very small, very unstable, very fragile, trying to form those difficult patterns on a conventional machine can be quite difficult, and sometimes the package handling reliability is not there. So a hybrid offers the precision of the robot, the repeatability of the robot, along with the speed capability, the layer handling capability of a conventional machine. So certainly repeatability, flexibility, accuracy, those are all factors that go into considering hybrid solution. Another benefit is we see many examples today where customers want a particular side of the package for the outside of the load, either a label or graphic display. The robot or the conventional gives that capability basically free. It's built in, whereas on a conventional you're going to have to add additional hardware to the machine in order to achieve the label out orientation. Another advantage, either of robotic or a hybrid, is that we have software, and Matt, I think you're going to touch on this, that allows the end user to program new patterns through the HMI. Don't have to come back to the manufacturer. The software allows you to add those new stacking patterns. And the patterns can be tweaked, I say, on the fly. So if a particular package is not handling to your liking, adjustments can be made right through the HMI as the machine is running to dial it in with the precision that is needed. Here are a couple of photos just to illustrate, and up in the upper left-hand corner is a pick-and-place robot stacking onto the apron of what would otherwise look like a roll-forming style palletizer. The advantage here is you get label-out orientation, you get a nice tight load because of the squaring dams on the machine, and at the same time the robot can apply the tier sheets between layers as needed. Here's what I kind of call a King Kong size hybrid machine, a pair of FANUC robots on a high-speed inline machine handling very large boxes of beef with the ability to put the labels to the outside and actually build mixed loads, order fulfillment loads at a very high rate. I might mention that the robotic technology can either be industrial arm like a FANUC or a dedicated use gantry type device, and that really kind of comes down to personal preference.
So when you say order fulfillment load, what you mean by that is a specific set of products are dedicated for a particular distribution channel, like you're building a pallet out for a particular order with a known set of products on that pallet.
That is exactly correct. The mixed load, mixed product, mixed SKU, and even mixed case sizes, and the hybrid gives you that capability. So I'm going to put this chart up, and you know, you say, well, golly gee, you know, you're kind of talking rates, you're talking footprint, talking flexibility. Where do I start? Again, I'd start by looking at the rate. Now, this chart is not intended to be the ultimate guideline in terms of what the capabilities are of these various solutions. It's simply to give you an idea of what the capabilities are. So for conventional, low in-feed elevation, we're typically talking in the range of 4 layers per minute at maximum. You go to a high-level roll-forming style machine up to maybe 8 layers per minute, or in terms of cases per minute, 70. With the high-speed inline, we see applications where we're doing 15 up to 20 layers per minute, or 200 packs per minute. Robotic, pick and place, again, think in terms of 8, maybe 10 cycles a minute for a really tight, well-laid-out cell. But again, to try to define that without looking at the specific application is very difficult. And then we get into the hybrid solutions. So you can use this as a reference, but certainly don't make any investment decisions based off this chart.
So another one of the things we talked about earlier was the different packaging types and other product requirements, and so those are all also impactful to the rates of all of the different types of machines that you've talked about here today. So back to emphasizing on selecting the right supplier or integrator for these solutions is you've got to take all these things in consideration when engineering a robotic palletizing solution.
Absolutely. So a couple other things. I haven't mentioned cost. Usually that's at the top of everybody's list. Well, what's it cost? If you say, well, what's the robot cost? What's the palletizer cost? It depends. There are a million variables that go into that, the system being one of them. So you need to look at the entire solution. Sometimes they come out darn near equal. Robot, hybrid, conventional, because of all of those variables, you put it in the hopper and it comes out where the cost is nearly identical. So then what do you do? Well, look what's going to serve you best long term. For your environment, your building, existing equipment, what are the capabilities of your facility in terms of maintenance operation? Are your people well skilled in robotics already? Then robots would be a simple decision. If you're more into PLC technology and just conventional machinery, well, then you might want to lean in that direction. Again, don't forget about future needs, flexibility, and then long-term support. As Matt was talking about the integrator, can you get that support and upgrades and so on for your equipment long-term? Sometimes it just comes down to this, the comfort level that you have. It could come down to a gut feeling. What do you feel that serves your needs the best, if all other factors being equal?
Yeah, so one other thing that I wanted to chime in here is the first bullet point you have is cost. Also focusing on the value that you get for that cost, because there are a wide variety of different costs associated with palletizing solutions, and certainly there are some very low cost but low value solutions. And so compare not only just the cost but also be very detailed on the different functionalities and the different features associated with the different solutions that can be provided, because even though the low cost may be low cost, it might not really get you what you need. So,
Matt, that is a great point. And we've seen many, many examples where someone decided to go with their low-cost solution only to be stung long-term
right.
by that.
Yeah, and not recognizing the challenges, a lot of those challenges that you've articulated here quite nicely. If you don't recognize and don't build those into the solution, you can get that low cost, but the value is not going to produce the solution that you need.
Exactly. So order fulfillment, we'll say a few things about this. Palletizing in a DC, order fulfillment. I mentioned earlier that we're seeing an increase in the use of totes. Totes provide a great mechanism for shipping goods that are in a picking operation. What we typically do is sort by orders into buffer lanes and release those orders to a palletizer. Now, on the surface, myself included, I'd immediately start thinking in terms of robots when I stack totes. However, what we find, given the rates involved and some of the challenges that go with tote handling, actually the conventional machine has some distinct advantages. So while we've applied totes, while we've palletized totes with robots, typically we will apply a conventional solution. This is a very small illustration, but just to show you, what we have is a sorter, high-speed sorter, come off into buffer lanes, accumulate by order, and then release those orders to a central palletizing area. And those orders or those loads would receive a label that would be applied to the load.
Yeah, so one of the important pieces here associated with doing an order fulfillment palletizing solution is the integration of the software, the overriding software that handles that order management piece. It's being able to fulfill those orders, release those orders as appropriate to those buffer lanes that Frank mentioned, and then being able to sort that down to the palletizer to put them onto the machine in the proper sequence, and that they're labeled and shipped out appropriately. All that has to be coordinated perfectly.
Which means software.
Which means software, right.
So if not totes, in an order fulfillment or distribution environment, the holy grail is mixed SKU, and that can range from very simple uniform case size, but different flavors, different colors, or whatever. Conventional machine can handle that just fine, as well as rainbow loads, where we do rainbow loads in conventional equipment where each layer is different, similar to the meat distribution job that we showed you a minute ago, but we mix within a load. Taking it up a notch in terms of complexity, sometimes we'll use what we call starter loads. So the first 2 or 3 layers may be homogeneous based on the order, and then stack the cats and dogs on top, either manually or automatically. And then we work our way up all the way to total mixed random loads, which is where the technology exists, but well, the system cost can get up there pretty good. So we're still in a, I'd say, still in a time frame here where ROI can be difficult, but as technology continues to evolve, labor costs can continue to go up. We are seeing viable applications for total mixed SKU palletizing.
Yeah, as Frank mentioned here with the mixed SKU palletizing solutions, generally speaking, there is a lot of additional hardware beyond just the palletizing piece to make that solution come together in an entire system. You've got, generally speaking, ASRS, you've got depalletizing solutions, you've got order release modules, and then you have some complex stacking algorithms to actually be able to generate that. So generally speaking, those are very high volume, very, very costly systems. In those scenarios are generally large companies that would merit that. It's not like you're going to have somebody that's going right from a manual palletizing solution into a complete mixed load order fulfillment solution.
Now, with that being said, there are ways to improve. Let's say you say, yeah, I've got to continue to manually palletize because I got total random. I just can't afford the millions of dollars that are going to be required to automate my palletizing. However, you still typically start with donor loads that have to be broken down, so maybe just automating the depalletizing side is the way to go. So if I step to this slide here showing different methods of depalletizing ranging from a semi-automatic approach to picking multiple layers off and unscrambling those layers, or even a vision-guided single-case depalletizing type operation.
Yeah, we could do a whole webinar series just on depalletizing alone here.
That's exactly right. So we've mentioned software a couple times. Let's talk a little bit about the importance of software and some of the options that are available.
Yeah, so one of the considerations that you have when you're evaluating these palletizing solutions is a common user interface versus a dedicated user interface. A user interface is, generally speaking, set up to configure your pallets and configure your products. There are solutions out there that have offline software that allows you to configure your pallet loads. Other solutions out there have a very cohesive, integrated solution to allow you to configure your pallet loads and your layer types on the machine itself. As I mentioned before, too, the integration of the software with the WMS or WBS is very critical to the overall application. As we mentioned with mixed load palletizing, it's not just a matter of putting the mixed load product onto the pallet. That's the tip of the spear. The remainder of this is all of that integration with that software to provide that solution.
And the ability to simulate as you get into more complex, whether it be robotic, palletizing, or mixed load, simulation is a key capability, which goes along with selecting the right integrator.
Yeah, absolutely. Generally for lower slow speed applications, you may not necessarily need to do it on every single solution, but when you're pushing volumes and pushing rates on these things and there's any doubt that you're going to be able to do it, having a software simulation performed on your solution is very valuable and can lead to some very insightful information.
So this slide, I think, just touches on the ability to program new stacking patterns through the HMI without having to reteach the robot. It's all graphic-based. If done right, can provide a great amount of flexibility and adaptability to the operation.
One other item that's been in the trade magazines and whatnot is the IoT capability of pulling information out of machines and doing data.
IoT being
Internet of Things, right? And so having the ability to provide useful and valuable information to the operations and maintenance is very valuable. And then other considerations as we pull, we'll look at maintenance and operations of do they have the ability to support the system? This gets back into that software again for configuring pallet loads. Now, as your patterns change moving forward, or you have a new product that is introduced that you didn't know about when you first purchased the palletizing system, do you have the ability to go back in and expand the capabilities of your machine, or do you have to go and add a lot of new hardware? You have to add a lot of new, or have to have some complex software to be able to handle this. So those are things that you should be thinking about as you move forward with the palletizing solution.
So that's our quick high-level overview of palletizing. Going back to that first polling question, many of you are, I think it was what, 40% manually stacking today. Hopefully we haven't scared or intimidated you. The reality is it's not rocket science. The fact of the matter is, particularly with conventional machines, they're pretty simplistic, and the greatest compliment from a customer is when they say to me, your machine's so simple, there's nothing to it. That's the way we want it. We want it to be simple. We want you to be comfortable with it. So what we'd like to do is open up to questions and discussion here. And we're happy to get into as many details or take as deep a dive as you like here. With that said, Tracy, I don't know if you control the questions or how we proceed with opening it up.
Absolutely. Thanks, Frank and Matt. Great job on that presentation, very informative. And we are going to move on to the question and answer portion of the event. And just as a reminder to all of our attendees to send a question to our presenters, please click on the question mark icon located in the floating toolbar at the edge of your screen and type your question into the text area and hit send. Please keep the send to default set as all panelists. And we do actually have quite a few questions that have come in, so I'll go ahead and start running through those. Our first question is, you mentioned challenges in palletizing totes, and this attendee would like to know how are those challenges addressed?
Okay, well, maybe first we'll talk about some of those challenges. Number one is that we find that the typical DC has more than one tote design. You glance at it on the surface, say, oh, these are all the same, and as you get into it, they're not. There's slight differences in height and shape and size, and that can create challenges for the palletizing operation. So we design into the equipment additional hardware that allows it to deal with those variables, and nesting is really, really key because we find that as luck would have it, typically the light totes are on the bottom of the load and the very heavy ones are on the very top. So that by nature creates an unstable situation, and it's not uncommon to go 7 or 8 layers high. So it's very important to achieve nesting where you don't want one tote sitting up on top of the lip of another one. So for that we add additional hardware, dams, compression guides, and so on that help to ensure that we get 100% nesting, or as close to 100% as possible.
Yeah, I mean, the overriding piece here is, like you touched on, there is no just common standard tote, right? All these totes are different in nature, and so there's an evaluation that must be done to those totes, and then once that evaluation is done, there's a variety of different things that can be brought to bear, whether it's a conventional machine or a robotic machine, to address those challenges. But it's not like one size fits all. You push the magic tote button and it functions. There isn't any one answer that is out there.
Exactly. And then there's nuances such as DCs have the habit of overfilling totes. So rather than nice flat top surface, it looks like a roof where the sides are sloped. That doesn't build a very stable load. So we have to detect that and train operational personnel, don't overfill the totes. So there's a little bit of training, a little changing in operation that goes on when you go to an automated process.
Yeah, so it relates to stability and whatnot. One of the things that we've seen brought to bear is the ability for like robotic palletizers to palletize on wrappers. And so when you've got unstable loads, whether it's totes or just unstable product, you can build the loads directly on the wrapper and wrap as you go. So even if you have those things like the chimney that you described there, you can inherently build stability as you're palletizing the load.
Right. Okay, Tracy.
Okay. Yeah, no, I was just, there's two questions that have come in that sort of play off what you just said, Matt, since you were just touching on the wrapping. There's a question about a requirement to shrink wrap pallet loads, and can shrink wrapping be integrated into a robotic or conventional operation, which you just spoke to, or does it need to be a downline separate operation?
So I'll speak to the robotic piece of this. So stretch wrapping absolutely is integrated into palletizing, and there's some advantages to do that with a robotic over necessarily of a machine. But like the stability is exactly that. You know, it's being able to make sure that as you're generating that load, that you've got a nice stable pattern. You also get some other advantages like reduced overall footprint if you've got a very tight space that you're putting your palletizing solution into.
Yeah, with respect to doing it in conventional machine, it is done. There's the advantage of the load stability that Matt touched on. However, typically in a conventional machine, you're looking for higher throughput. And at that point, the wrapper becomes a hindrance. That really is the throttle to the machine at that point. And with it so closely coupled, unless the load is just so unstable it can't be conveyed to a wrapper, there's really advantages to having them as separate operations when you get into the kind of rates that you would typically want to use a conventional machine for.
Yeah, especially just like what you said there. When you've got a high rate conventional palletizing machine, you don't want to impact that rate, so you really want to separate those two and have some level of buffering between the two so you don't impact that pallet.
And then if the film breaks, by having a buffer between them, you have time to react and get the film going again and so on.
Okay. If I have frequent new product or load pattern changes, which solution, robotic or conventional, provides a user interface that allows for easy product and or pattern changes?
Well, that's a great question, and it's a tough one to answer because of the variables that go into it. With a conventional machine, well, for both conventional and robotic, we have pattern utility, pattern creation software that allows the end user to create their new patterns. With a conventional machine, depending on whether it's a roll forming style or an inline, there are hardware considerations that need to come into play. For example, to generate voids between cases on a roll forming style machine, you need package stops or row stops. So those have to be in place. So if they're not there, they'd have to be added, but the software allows you to create those stacking patterns. With a hybrid machine, the type where the robot is forming the layers, absolutely there's a ton of flexibility there, and I won't say that there are no circumstances where hardware has to be added, but in most situations, new patterns can be programmed very easily by the end user, which also is true of robotic palletizing as long as the end-of-arm tooling lends itself to it.
Right, yeah, and you certainly got a variety of different types of end-of-arm tooling, whether it be vacuum, clamp, or fork-style tooling, but robotic solutions really, whether it be conventional or hybrid or traditional pure robotic solutions, really lend themselves towards the flexibility of being able to handle a wide variety of different types of products. So, and the software that comes along with that allows to leverage that mechanical flexibility so that it can create a pretty wide variety of different pattern types and load configurations.
So Tracy, I guess the short answer to that question is yes.
Oh, that's exactly what we're talking about.
Perfect. Well, Matt, sort of playing off something that you just mentioned, my next question is, can a single robot solution use 2 or more different tools, and how is that changeover handled?
So in general, yes, it can. So it really depends on the types of, there are tool changers. So at the end of arm tool, between the end of arm tool and the robot is you can do an automated changeover device. We haven't seen that very prevalent. Generally speaking, we try to avoid doing that if at all possible, and design into the tool the capability of handling the product type. There's some pretty interesting things that you can do from a customization standpoint to allow you to handle a pretty wide variety of different types of products without requiring to do tool changing. With that said, certainly the capability is out there, and you know, it's a viable technology.
All right, thank you. Let's see here. I do have a few more questions. The next question is, I assume it's a good idea to see if a potential supplier can demonstrate palletizing methods using my product before I decide what is best for me. And is something like that generally possible? Do you see that a lot happening in this industry?
We do see it a lot. In fact, often we're the ones requesting it, because if a customer has a unique package, something new, something different we haven't seen before, or has stability concerns, often we'll want to do testing on that product to demonstrate not only for the customer, but for ourselves. So there is a high level of confidence going into the project that indeed we can handle it very reliably. Yeah,
so you couple that with some of the other capabilities. So it's not necessarily that you need to do all of the products that are part of the scope. It's generally speaking, there's a few products that are of concern, so you would want to do some physical testing. And then there's also, you couple that with other kinds of things like just basic calculations as well as the simulation. So you can bring together a whole host of different ways to understand what those challenges are and make sure that those things are addressed before you move forward with actually the project.
Well, and another question has come in about testing. This question is, are robots or palletizers set up in a vendor's facility before they ship? In other words, are factory acceptance tests normal in this industry?
Yes, they're very normal. In fact, we encourage customers to come in, see the equipment run prior to being installed in their facility. So that is a very common practice. Some customers will have their own methodology of things they expect to see, and we'll see factory acceptance tests that last an hour, and we'll see some that go for 3 days, depending on how much detail we want to get into, and sometimes we'll do a little informal training at the same time.
Yeah, and sometimes, depending on, like, I'm thinking about robotic cells specifically, it may also be graduated. So there may be numerous cells that you're proceeding forward with, so there'll be an extensive evaluation of that first cell, and then as further other cells are deployed, you wouldn't necessarily need to do that to the same level that you do the first one.
Great point, Matt.
You reduce that amount of time and complexity because you address all of that in the initial round of testing.
Exactly.
Okay. Let's see. Is the difference between row forming and inline palletizing strictly a rate parameter, or are there applications better suited for one or the other?
Yeah, traditionally a row forming style machine offers greater flexibility than an inline machine. With that being said, today we're handling products and patterns on inline machines that 4 or 5 years ago I never would have dreamed to be possible. Particularly when you add robots in combination with the inline machine. But generally speaking, row forming provides greater adaptability, greater flexibility, and it's a little bit simpler from the standpoint of training operators to know how to operate the equipment. But inline machines are getting more flexible all the time, and we're doing multi-line today with inline machines. That is, one machine handling multiple packaging lines simultaneously. So changeovers occur automatically. So you might see product A followed by C, followed by B, and all that takes place on the fly.
Okay. You spoke to this a little bit earlier, Matt, but my next question is, do robots always make a single case carton pick, or can you pick multiples?
Yeah, absolutely, you can pick multiple. Yeah, it's all dependent upon the tool.
not only pick multiples, but place multi-drops.
Yeah, right. So absolutely. So, and not only that, but then there's also opportunities to be able to form rows and pick entire rows of product, and in some instances, pick entire layers of product. So it is very tool dependent. And again, you know, I kind of sound a little repetitive here about the software piece, but to being able to do those row picks or multi-row picks and doing those multiple drops in different configurations, mechanically the solutions are very capable of doing it. It's a matter of making sure that you've got the software to be able to manage that all of the complexity involved with all of the positioning of the robots to set the product in the right place and the right number of products in that particular orientation.
And with the multi-drop, it allows us to do very complex patterns, but picking multiples, get complex patterns, and still get a really decent palletizing rate out of it.
Yeah, and there's also two flavors of that multi-drop too. You have one where you have multiple cases that you pick all in one configuration. You set them all down in one configuration. But a multi-drop means is that you pick up several cases simultaneously, but then set individual cases down in different orientations and locations on the same pallet in one operation.
All right.
So
okay.
yes, it's all possible.
All right, well, I think we have time for just one more question, and it is, are you seeing an increase in robot palletizing versus conventional, or is it pretty static?
There's definitely been a trend towards robotic palletizing. I'd say over the last 5 to 8 years. In the last year to 2 years, it's kind of stabilizing a little bit. There's still probably some trend towards robotic, but it has somewhat stabilized. And we see both. And as some of the parameters we went through, I think a lot of that trend was driven by the fact initially that robots are cool. They're fun to watch. They can do some cool things. And now I think customers are taking more of an analytical approach. What really makes the most sense for my operation? And so, yeah, there's probably still a little bit of a trend towards the robot, but it's not at the rate that it was 3 or 4 years ago.
Okay, well, thank you. I think that's probably all the time that we have for questions today. So thanks to all the attendees for their participation, and thank you, Frank and Matt, for all of your answers. If we were unable to answer your question during today's live event, we will send you a response via email. And as a reminder, within approximately 24 hours after this live event, you can access this presentation on demand at intelligrated.com/on-the-move. You'll also receive an email in a couple of days with a link to the recorded event, along with a link to download a white paper by Intelligrated titled Conventional versus Robotic Palletizing. On behalf of Intelligrated, thank you for attending today's On the Move webinar. Please join us on November 17th at 2 p.m. Eastern when Mark Steinkamp discusses trending solutions for omnichannel. Registration will be open on our website soon, and we hope you will join us then.